I'm Allie Wilson, and I'm a grad student at New England College. And for my action research project, I decided to answer this question: how using the multiple intelligences to build math proficiency in a 5th grade classroom can help my students. So that's what I researched this for the past 2 years. So the question here: how can the use of multiple intelligences help build proficiency in basic math skills? This was the question that I researched. I found that through teaching, 5th graders are coming to me with a lot of gaps in their basic math skills. So I really wanted to focus my study on building these strengths and helping them to gain the good math skills. I believed that the multiple intelligences, Howard Gardner's theory of the multiple intelligences, would be the best way to go about the study. I feel like students will work better when they're interested in their learning and have ownership in their learning. And I felt through the multiple intelligences that would be a really good route to take in the study. So students need to know their strengths, and I feel like that is one of the reasons why using multiple intelligences in math is important. So allowing students to learn what their intelligence is was a big part of my study. Pairing interest and strengths will produce results and build confidence. I feel like when students are able to work on something that they know they're good at, their confidence will naturally soar, and I feel like with that they will produce positive results. Interest is sparked when students learn through their strongest intelligence. As I said before, when students are invested in their own learning, I feel like they will take more away from the lessons and the skills, and the understanding will be more deep. So the participants in my study was a heterogeneously grouped class of 5th graders. There was 13 students that I got consent for to be part of the study. 3 out of the 13 students in the study were identified with a learning disability. So the steps of my project: the first thing I had to do was get consent from my principal and parents. And after doing that, I conducted a multiple intelligence test to my 13 students. I wanted to find out what kind of learner they were. And once I did that, I had the students do a reflection on how they felt they were feeling about math at this point in time in the year. And I used this reflection to look back at the end of the study and compare results. One part of the reflection was a drawing of them visually, how they look and feel about math, and then they also had to write in a sentence or two about how they actually felt. After I did the reflection and the intelligence, and I found out what their intelligence was, I administered a pretest. This pretest was all basic math skills, from adding, subtracting, multiplying, dividing, fractions, graphing, all the basic foundational skills of math. So I took this data and I put it away for the beginning of the study, and I was going to come and pull it back out at the end of the study to compare my results. The next thing I did after the pretest was I planned my multiple intelligence activities for the students. So I had my different learners in groups, and I created activities around them, around those intelligences. The next thing I did was I implemented the activities and collected data on the students daily. And the last thing I did in the project was I administered a post-test and a post-reflection, which was actually just the same exact test that I gave in the beginning and the same question: how do you feel about math at this point in time? So this was my result bar graph for the types of learners in my class. So I had 3 spatial learners, 1 musical learner, 3 kinesthetic students, 2 interpersonal learners, 2 intrapersonal learners, and 2 naturalist learners. And this is an example of the multiple intelligence survey that I gave the class. Just as Diane Kono from Brain-Based Strategies to Reach Every Learner. It was a Scholastic book, so that was a really helpful tool in the study. So this was the prompt that I gave the kids for the reflection piece. How are you feeling about math right now? So this was kind of the big question that I wanted the kids to really dig deep and tell me how they felt they were as a math learner at this point. The students drew how they felt, they wrote how they felt about math at this time. The same prompt was given at the end of the study and the results were compared. So this is an example of student A's reflection before the study. The drawing shows a straight line face, not happy, not super sad, and the written reflection says, the way I feel about doing math is in the middle. Sometimes I'm struggling on some stuff, but most of the time I get math. And then this is the same student after the study, and now he's sitting at a desk, he has check marks on his paper, he's smiling, he's holding a pencil, he's sitting up straight. So to me that showed he feels more confident in himself, his mouth is now smiling and not so straight. And his written response is, the way I feel in math is good because everything they're doing in math I get. I need to work on it more. So I liked that he was able to say he's got some sort of goal that he's trying to reach. So I felt that was a positive result. So then I took all of the students' drawings and reflections and I created a graph. The orange indicates before the study how they felt about math, and the blue shows after the study how they felt about math. And the themes that came out through these drawings were happy faces, sad, frowning faces, and straight line faces. So those were the three themes that I compared. At the beginning of the study, there were 6 students who had happy faces, and at the end of the study, there were 10 students that had happy faces. At the beginning of the study, there was 3 kids that had sad, frowning faces, and at the end of the study, there was only 1 student that had a sad, frowning face. And then at the beginning of the study, there was 3 students who had a straight line face, and at the end of the study, there was only 1 student that had a straight line face. So the results definitely reflected that the students' overall feeling about math got better after the study. So the activities and the exit slips. The exit slips were given every time we met and did the multiple intelligence activities. So they were given a rating scale that they had to complete at the end of each activity. A 5 meant that they felt very confident, they were able to apply the skills to help me in the activity. A 4 was good, I understood most of the activity. A 3 was they were bored, not excited about the activity. A 2 was they were uncomfortable, I still have questions about the topic. And a 1 meant that they were outside their comfort box, they were more confused. So that's the rating that I used for those exit slips every day. So some of the kinesthetic activities I created for my students was math fact, trash can basketball, I have, who has, fly swap math facts, and around the world with math facts. These kids are active learners. They need to be involved with moving and using their bodies to learn. So they were up and doing things every time we met, and they really seemed to really like these activities. For my musical activities, I only had 1 musical student in this study, and she wrote a song for math facts. She performed her song for a friend, and she wrote a song and did some little clapping rhythm for math facts. And she enjoyed this as well, and you'll see that in the exit slip results. My interpersonal learners. My interpersonal learners are the people that communicate together. They learn best working with others. There was 2 of them in my class. They worked on a jigsaw activity where they would both have a separate assignment that was similar in skills. They would work on it by themselves, and then they'd work together on each other's problems and kind of talk about it. So I used the jigsaw model with these kids, and they really liked that. They did a class presentation on a skill they were working on together, and then they also did problem solving in pairs and teaching a skill to the class, which they liked because they were able to get up and talk about what they were learning about. These are the kids that like to communicate and like to talk about what they're learning about. So the intrapersonal activities, these people are self-smart, which means that they learn best when they're by themselves and when they are in a place where they can learn with quiet and kind of just in their own thoughts. So I gave them a choice board at the beginning of the study, and they could just go through the choice board and choose what activities they wanted to do during that time. Some of the things they did was write a letter to a friend describing a math concept, write a letter to the teacher about a math skill, and then they would write in their reflection log at the end of each session. My naturalist learners, I found this was one of the harder ones to find activities for, but I think this group did a nice job. I integrated science concepts into the math skills. I created word problems that had to do with outdoors adventures, and I posed real-life problems to them that they had to solve. My spatial learners. These were my kiddos that really liked to create visual anchor charts, and they liked to show their knowledge through creating something that was spatially and visually appealing. So they designed anchor charts for the math classroom. They designed posters, handouts, and other visuals to explain a math skill, and they used the visuals to complete their own math work. So these are the exit slip scores. I created a chart with these scores from each activity, each time we met. The scores indicated that majority of students were very confident or felt good about their understanding. There was only one student who scored all 3s in the study. So these were the pre and post test scores. So we have the number of students and we have the skills. So the skills are along the bottom. We can see that multiplication, the pre-test score was, so the number of students who received a 2. So a 2 meant that they got it. A 1 meant they're approaching the skill. A 0 meant they didn't get it at all. So this number here demonstrates or shows that this is the kid that got a 2, so they got the skill. So before the study, only 8 people understood the multiplication. Now we have 13 people understanding multiplication. Before the study, we had 5 understanding division. Now we have 9 understanding division. Addition, we had the beginning of the study, 10. Now after the study, we have 13. Subtraction, we had 9 students at the beginning of the study. Now we have 10. Multiples, we have 2 kids that understood multiples at the beginning, and now we have 6 who get it after the study. Factors, we have 4 that showed that they understood it before the study, and 5 after the study. Odds and even, 8 people got it before the study, 10 got it after the study. Graphing, we have 5 people that got it before the study, and now we have 7 people that got it. Fractions, we have 3 people that got it at the beginning, and then we have 6 people that got it at the end. Decimals, we have 3 people that got it at the beginning, and now we have 6 people who got it at the end. So obviously we can see from the pre and post test scores went up in all areas from pre to post. Results and analysis. So student scores went up on all skills from pre-test to post-test. Student reflections were much more positive after the study in response to the question, how do you feel about math? So my conclusion, I revealed that by using the multiple intelligences of math, students' basic math skills will improve. Student reflections, post-test data, and exit slip scores all indicated an overall increase of proficiency. So next steps, key findings. If I was to have recommendations for anyone to do this study after this, I would give a multiple intelligence survey to students at the beginning of the year. Create activities centered around student intelligences throughout the year. I would help other colleagues learn about the multiple intelligences and how to integrate them into classroom activities, maybe not just math, maybe we could reach out to other subject areas as well. Provide a variety of strategies for students to use their strongest intelligence throughout the teaching year, throughout the school year. Educate students about their strong intelligences so they recognize their strengths, and I think that's a really important one to kind of key in on, and educate the students about how they learn best and teach them what these intelligences mean. I didn't mention at the beginning, but I did talk to the students about their intelligence when they were identified with what their biggest intelligence was, so they knew a little bit of information about why they were a musical learner, why they were a naturalist learner. And they all really did agree with what kind of learner they were. Provide students the chance to reflect on their feelings about math and use the data from these reflections to drive instruction. So these are things that really worked well in the study, and I would definitely continue moving forward to implement these things. These are my references that I used throughout my study. Numerous articles and books were used. And those references continued. and thank you so much for listening to this presentation. And I think overall my study showed that students definitely became more proficient with their math skills. Thank you.